Yes. So today we will make this one axial fan. Okay, axial fan. So the axial fan. So axial fan is like when the air flow parallel to the axis. Okay, parallel to the axis of the fan. So then that fan is known as axial fan. Okay, in the axial direction. Okay, flow is in the axial direction. Axial, right? Axis. Axis means right this one, central axis. So if the air flow in the direction parallel to that axis, so then that fan is known as axial fan. So the shape of the blades are like lines. When we view from the top, okay, the shape of the blades are like lines. So yeah, here one line and here another line and here another line. So these lines are not like all are in the same orientation. Okay, so suppose when we consider this one, okay, so this is at an angle 30 degrees. Okay, and when we consider, so this is at an angle 30 degrees, 30 degrees, and when we consider some other place, so the angle may be different. Okay, and when we consider top, so angle is different. Okay, so the angle is different, so the angle is changing. Okay, when we go like this one, angle, this angle is changing with height. Okay, so yeah, this is a type of design, axial fan type design. Okay, so yeah, we calculate this angle based on some formula. Okay, there is some theoretical formula is there. So from the fluid mechanics. Okay, so we have some theoretical, so from theory we use some theory and calculate this angle. So I just give here random. Okay, just random angle 30 degrees. Okay, I did not calculate from some theory and all. So just here 30 degrees. 30 degrees is where here at the hub. So this portion is known as hub. Okay, so shaft. Okay, shaft of the fan is known as hub. Shaft or hub of the fan. Hub is a technical term, is hub. And this portion, right, this is known as tip, right? Tip, the outer radius. So tip. Okay, tip. And in the middle, so we have some imaginary circle. So that circle is known as the mean circle. Okay, center, mean radius. Okay, so hub radius. Okay, hub radius is, suppose this one is RH and this one is tip radius. Okay, RT is a tip radius, and the mean radius is R mean is equal to, so R hub, average of those two radius, R hub plus R tip. So tip means just outer radius by 2. Yes, here I just consider 3 angles. Okay, I'm just making 3 lines. Okay, so one line is at the hub, one line is at the hub, one line is at the hub at an angle 30 degrees. Okay, so 30 degrees. So this is the hub angle. A blue color line is hub. Okay, so blue color line is hub, and so this purple color, pink color line is at a mean radius. Okay, at the mean radius. Mean radius means here. Okay, this one, and at outer radius or tip radius. So this is the line. So we have to create 3 lines. One line is at the hub here, the blue color line. Okay, blue color line at the hub, and uh, pink color line at the mean radius. Okay, so at an angle 45 degrees. Okay, so these angles are from a theoretical formula. So but here I just gave some random angles, 30 degrees, 45 degrees and 60 degrees. Okay, so 60 degrees is the white color line at the 60 degrees. Okay, yeah, at the tip. Okay, so I just only consider 3. Okay, actually there are many number of lines, right, in between hub and tip. So how many number of lines possible? Infinite number of lines. Okay, infinite number of lines, right, in between this and this. But just I am considering only 3 lines here. Okay, infinite number of lines. So generally we can consider maybe 10 sections. So 1 2 3 4 5 6 or 10 sections for accurate. Okay, so for accurate shape of the blade. Okay, you know, right, accurate means correct shape. Okay, correct shape. So this is not correct shape. Okay, just I just considering at the hub and at the mean radius and at the tip, only 3 sections I am considering, right? So if you want to get more accurate blade profile, you have to consider more sections. Okay, at different radius, different angles, find from theoretical formula and draw lines. Okay, okay, let's go to the straight into the. So first, hub radius. So hub radius is here given. Hub radius is a diameter of the shaft is given. Okay, 100. So the hub radius is 50. Okay, and tip radius is, so diameter of the tip is given 300, right? Tip means outer. So tip radius RH is this one, RH, and R tip is 150. So what is the mean radius? RM is average of those two, 150 plus 50 by 2. Okay, 150 plus 50 by 2. Yeah, this one. This is the mean radius. Okay. So we have to draw 3 circles. So here one circle and here another circle. Okay, cylinder, 3 cylinder, and here another cylinder, 3 cylinders, and project. Okay, project those lines. Okay, draw line here and one more line here, one more line. So line, so same dimension, line is same dimension, 60, 30, but angle is only different. So this is 30, right? This is 30 and this is 45 and this is 60. Okay, okay, so let's get into the CATIA. So start, shape, generative shape design, generative shape design. So I'm making the center point of the cylinder. Okay, I'm using the cylinder, okay, not circle. So you can draw sketch. Okay, sketch and extrude. So this sketch and extrude. So I'm using cylinders here. So cylinder center coordinate is 0 0 0, and so what is the cylinder length? So length of the cylinder is 100. Okay, 100. So 50 50. Okay, 50 50 50 and 50. Okay, so total 100, and so 50 one direction and another 50 another direction. Okay, so cylinder, so center point of the cylinder is this one, center, and axis is what? Right click your mouse, you have to select the axis. Okay, center axis is x-axis, right? X-axis. So this axis, so this axis is x-axis, right? X-axis. So z plane, right? So x-axis. So right click your mouse and x component, and so radius of the cylinder is hub radius is 50 millimeter, right? Diameter is 100. So one length is 50 50. Okay, 50, and I am using mirror extent, or 50 here, 50 here. So that is one cylinder. 500 is given, so just 50 millimeter. Okay, And now draw a line. Okay, draw a line. Hub line. Hub line is this one. So shape of the axial fan blade shape at hub is this one. Okay, so 60 line and yeah, 30 from here to here and 30 degrees angle. Okay, so where we have to draw that one? We have to draw here, but here there is no plane, so create plane first. So from XY plane, create new plane. So at an angle, at a distance, right? Hub radius is 50, so 50 millimeter radius. Okay. And here line. So create line. So make sketch there. So line, like 60 degrees line, yeah, here. Exactly like as in that figure, 60. That line should pass through the center point, right? Here, you can start line from anywhere, okay? But here, so it should touch the center, okay? Not like this one or not like this one. It should pass through the center point, okay? So this length is 60, okay? This length. So you should give this one outside. So many students are clicking here, right? So that is interfering with the cylinder, okay? Outside the cylinder, you have to give the dimension, okay? So you should bring your mouse outside, not here, outside, okay? So 60. And again from here to here, half of the 60, right? So 30. That is also not on the cylinder, okay? So location of the dimension, right? Ending location of the dimension when you select this point and the center point, okay? Center point. So when you click here, that is interfering with the cylinder, okay? Not click. Don't click there. Don't click. Click, okay? Outside. It's 30. And the angle is 30 degrees. So from here to here, the angle is. So again, this also. So yeah, when you give that angle, so this line and this line select, not here, okay? So sometimes it interfere, okay? You have to provide that one outside the cylinder. Or you can hide that cylinder if it is interfering. Hide and give the dimensions, okay? You can give anywhere. Yeah, 30 degrees, sorry. So 30. Okay, so 30 degrees. Okay, so that is the hub line. And now again, we have to make the another plane, right? Another plane. So mean radius. I have to draw this one. I'm considering the mean section, right? Purple color, this one. So draw this line. So 45 degrees. So same length and same 60 degrees and 60 millimeter and 30 millimeter. So but this one is 45, okay? So you can copy that sketch and paste and change the angle, okay? So that is the easiest one. You don't need to draw again. You have first create plane, right? So from here, mean radius is 100, right? So mean radius is 100. So 100 is, and again create another plane at the tip. So tip radius is 150 from the center. So 150, and copy this one. Sketch one is same, length is same, right? Only angle is different. So you can change that one angle. So copy sketch one. So copy, paste, okay, paste, Control V. And here plane 3 disappear, right? Plane 3 disappear much. That means even though plane 3 is not hiding here, disappear. So in that case, what we do is right click there, define in work object. So plane 3 go somewhere else, not in the work object. Okay, you have to define. Yeah, when you copy and paste, these things happen. Okay, so you have to be careful here. Plane 3 you already drawn, you already finished, but you cannot see that one, right? So that means it disappeared. So right click, define in work object. Okay, define in work object. And again, you can either copy this one here, or you can copy this sketch here. Copy sketch 1, paste. Okay, yeah, paste. And now we have to modify the angles, right? Blades are twisted configuration. Okay, so yeah, design of axial frame, when we design, the blades are twisted. So at hub, this is the angle. At the mean radius, this is the angle, and at the tip, this is the radius. Okay, okay, so yeah, so change the angle. Sorry, that angle, not radius. So at the hub 30 degrees, and at the mean 45 degrees, and at the tip 60 degrees. So I click the mean sketch, right, at the mean. So that is a 45 degrees angle. And again, at the tip sketch, change. So we have to change this to 60. Okay. Yeah, so 3 different lines at the 3 different planes. Okay, so this is at the hub. Okay, this is at the mean, and this is at the tip radius. Okay, so angles are different, so change those angles. So if the lengths are different, you also have to change those lengths. Okay, so yeah, you need to change those lengths. Okay, if the, or create new sketch. Okay, if many things, if you want to change many things, means better to create new sketch. Yeah, now, yeah, I have to project this line to this cylinder, and I have to project this line to another cylinder, right? So mean radius cylinder, and I have to project this line to tip radius cylinder. But here now only one cylinder is available, right? So that is at the hub cylinder, and create mean radius cylinder. Mean radius is 100, right? So starting point, center point is this one, same, and the direction is x-axis same, and lengths are same, but the radius different. Only radius is different. Okay, click on OK, and again tip radius cylinder. So tip radius is 150, and center point is this one, and direction is x-axis. Okay, x component, and same length 50-50. Yes, now project. Okay, project this one to this. So project this one to this, project this one to this. Okay, so we need to have 3 projections. Okay, 3 lines, 3 projections. Okay, 3 cylinders. So projection, normal type projection, normal. So project this one to here, click on OK. Yes, so projected one is sketch 1, right? Sketch 1, cylinder 1. Okay, support is cylinder 1. So click on OK, and so next, again projection. So projected one is sketch 2, and support is cylinder 2. Okay, and again projection, projected is sketch 3, and support is cylinder 3. Okay, so click on OK. So here only thing I need is projections. Okay, so I don't need any all these sketches, and all remaining, all those things you can hide. Okay, except cylinder 1, I need that one, and project 1 and 2, 3, I need these 3 projections. So remaining things hide, okay, hide. Okay, yes. Yeah, now these are the blades shape, right? Cross sections. Now I have to generate blade. So blade shape. So if I can use multi-section surface, I can use multi-section surface, right? So join this line, and this line, and this line at a time using multi-section surface. But I don't think multi-section surface work here, because multi-section surface doesn't work here, I think. So because these lines are very twisted, okay, twisted lines like. So let's see whether it is whether the multi-section surface is working or not. Okay. So this line and this line and okay, yeah, and section 1 and section 2 and section 3, and directions also same, right here. So same direction. Okay, see, you see the arrows like this one, so like this one and like this one. So when you click on OK, there's some error. As I expected, multi-section surface is not working. Okay, not working. So because the blade's shape is very twisted, okay, twisted configuration. Or let's see if okay, if with guides it is working or not. Let's see, polyline. So select this point and this point. And if the multi-section surface is working, then you don't need to use blend, okay. Yeah, with guides, okay, with guides. So multi-section surface with guides. Let's see. So yeah, this one and this one and this one. So guides, 2 lines, okay. Oh, it's working, yeah. Okay. So that is one choice. Okay, we have to. Okay, I explain again. So multi-section surface with guides. Okay, guide is, yeah, we have to join lines, right, like this one. So lines like this one. So use polyline. So lines means you can only join here and here, 1 line, 2 line. So 3 line, 4 lines. You need 4 lines, right? 4 lines. But if you use a polyline, single line, okay, single line. Okay, so polyline. So this one and this one, that is polyline 1, and again, so this one, and this one, that is polyline 2. Okay, if you want to use a line, okay, so you can join just line, only single line here, line 1 and line 2. Again, we have to join after making line 1 and line 2. So 2 lines, separate lines, okay. So and use join, but here polyline is okay, polyline. And multi-section surface, okay, multi-section surface. Okay, and guides, you have to use guides, okay, guides. So click on guides. So guide 1 is this one, and guide 2 is, click on OK. Yes, that is the blade profile. Okay, after you're done with the creating grade profile, you can give thick surface, okay. Yeah, but here, if you don't know how to use multi-section surface with guides, another choice is use blend, okay, blend. So join this sketch and this sketch, and join this sketch and this sketch. Okay, so use blend. So blend. So first curve is that one, and second curve is that one. And we have to use two blends here, two blends. Okay, and join two blends, because blend means I can only use two sections. Okay, two curves, only two curves at a time, not three. And again blend. Okay, again blend. So this one and this one, two blends. Okay, yeah, after making blends, okay, this blend is different and this blend is different. Okay, so blend one, right, and blend two, so those are different, and you can combine blend one and blend two, join. Okay, join. So blend one and blend two, so make two blends as a one section. Okay, one surface. Okay, yes, after that, so the blade surface is finished. Now so after making, yeah, welcome back. So after making the blend surface, okay, this one, right, this one, so those projections are not needed. Hide. Okay, just hide those projections. I am using generative shape design. Okay, still generative shape design for making edge fillet here. Okay, edge fillet. So because here this edges, this do not have edge, this one is just corner, we cannot make edge fillet. So what I do is what I do is I have to create corner, right, corner. So but creating corner, I don't have sketch there, I have to make sketches, right, sketches. So sketches means just line, extract. So you can use boundary, right, extract those edges. To extract those edges, right, you can use boundaries. But when we use a boundary, it's completely extracting, right, completely extracting here and here. And so the problem is, when we completely extract, I want to make radius only here. Okay, only here. So it's not possible to use 3D corner, okay, when completely extracted. Okay, completely, I mean everything I cannot make. Yeah, if we use this one here also, that is making corner. Okay, here also that is making corner, so this is not correct. So what I do is, I use extract. Okay, extract separately, I mean this one separately, this one separately, this one separately. So you can use extract one by one using after boundary. So just extract this line and again click extract this line and again click extract this line or edge. But multiple extract means you can select all these three edges at a time. Okay, so I choose multiple extract. So select this line, select this edge, yeah, these three edges, right? So now these three are separate lines. So this line is separate, this line is separate, so this line is separate. So yeah, from bottom I don't need, I just only need here only. Okay, corner, right, 3D corner here only, radius 20 millimeter. So this I don't need. Okay, so when we select boundary, everything is getting selected, right, that's the problem. So click on OK, multiple extract. Yeah, one more time, here I'm using multiple extract. Okay, and boundary, extract, multiple extract. Yeah, this one and this one and this one. Okay, so click on OK. And now make corner, right? Make corner here and corner here. So 3D corner. So radius 20. Radius 20. Okay. So go to 3D corner. So corner on support node, 3D corner. Okay, because this one is twisted blade, right? This is not planar surface. It's not planar surface. It's a curved surface, right? 3D corner. We have to select 3D corner, and here corner on vertex select. Okay, corner on vertex. Yeah. So corner on vertex, and radius is 20 millimeter. Radius 20 millimeter. And which one who selects? So the multiple extract. Okay, this one. Okay, click on OK. Yes, now I have to delete this, right? So delete that one. So how to delete that one? So to delete that one, first, yeah, first I have to create extrude surface. Okay, so I cannot delete directly. So trim, right? So trim one surface with another surface, or delete, split, not trim. So only I want to delete this one only. You have to use split. Okay, so not trim. So we have to use split. So delete only this one and this one. So but we have to create surface from this one. Okay, we have to create. So why I made corner there? I have to create surface. Okay, this surface. So like this one. Which tool we have to use? Extrude. Okay, we have to use extrude. So extrude. Yes. So the profile, yeah, and here we have to use specific direction, not normal direction. Okay, not default direction. So yeah, so what is this direction, right? This y direction. So y along the x, sorry, I mean along the, yeah, like this one, right? That is y direction. Okay, so y component. Okay, y component, and you can choose length anything. Okay, so that surface I don't need, just only for splitting purpose I am using. Okay, that one. So click on OK. Only for split I am using. Later I don't need this surface. Okay, click on OK, and here hide this one. That is a sketch I don't need. And split, you have to use split here. Okay, not trim, because I have to delete only this one, right? Split, cut elements to cut is what? This one. So this join, right? So this join. And cutting elements is what? Cutting elements is the surface I created. Okay, and it is cutting below other side. So this one, right? I need to delete other side. So click on OK. Okay, and yeah, hide this one. This is not needed, just only for splitting. Okay, I'm using that one. Only for splitting purpose I am using that one. Okay, so after making the blade, so go to part design. Part design. So thick surface. So 1 millimeter and 1 millimeter. A thick surface. I need to give thick surface. Blade thickness is 2 millimeter, right? 1 millimeter and 1 millimeter. And close this surface. Close this surface. Okay, close that surface. And hide. This cylinder is not needed. Hide. Okay. And after making this one, what I have to do? Yeah, and also I don't need this one. Hide. Hide this one. Everything hide. Okay, except this two. These are the final, right? Final things I need. This one and this one. And after that one, arrange it, right? Arrange this one, 12 blades, 12 blades. So use pattern, so circular pattern, and instance is 12 and the angular spacing is 30, or you can use 360 by 12. And reference element is either you can select this edge, or you can select XY plane, or sorry, YZ plane. Okay, so YZ plane, or you can select X-axis. Okay, X-axis. So click on OK. Yes, that is the final shape of the blade. Okay, so final shape of the blade. And also, yeah, some things remain here. A chamfer C5, small thing. So this edge and this edge both are chamfer, so 5 millimeter. Okay, so that is the final shape when we use generative shape design. Okay, complete generative shape design. So generative shape design. So complete means up to here. I mean, after split and so give the thick surface and closed surface and axis chamfer. I give in part design. Okay. Is here after making this one, right? Before, after join, I don't want to use generative shape design to create fillet. Okay, to create fillet, and yeah, create fillet, and yeah, no split and no extract, no tools, just thick surface and give the edge fillet. Okay, directly in the part design. Let's see what happened when we do that one in part design. Okay, so first give thick surface. Yeah, first close this surface. So close surface, cylinder is not needed. So close this cylinder, close surface, and thick surface. So this one, 1 millimeter and 1 millimeter. And join hide. Okay, join means in the middle, right? That is in the middle. Join hide that. So give the edge fillet here. So 20 millimeter. Let's see what happened when we give the edge fillet there. 20. So these two edges, edge fillet, 20 millimeter. Okay. So after edge fillet, give the pattern. So current solid. Okay, everything. This one and this one and edge fillet, everything. Okay. So current solid means, yeah, current solid, right? So pattern, you choose current solid means everything. This one, thick surface and edge fillet, everything, and 12 and give 30, and reference element is this one. And click on OK. So you get some error, internal error. So because of the fillet. Okay. So fillet I have given in part design, right? So 12 blades we cannot make. Okay, so there is some error because I created fillet in part design. Okay, so you can select 10 blades and 45. I think it works, but this is not correct way. Okay, okay. So wait again. So 10 and 36 degrees. Okay, pattern. So 10 blades and 36 degrees, right? not 45. Why? So reference element is this one, and click on OK. So for 10 blades it is working, but for 12 blades not working because of some fillet error. Okay, fillet error. Okay, that is the party design when we use directly and chamfer. So only 10 blades I can make. Okay, so the correct way is here. Okay, the correct way is use the generative shape design and use 3D corner. Okay, extract these edges in 3D corner and create a surface from 3D corner and split, and after that thick surface. Okay, you have to do those things. Okay, that is the end of this lesson. Okay, finished.